How you doing, everybody? Randy Richard in the shop. I need one of these, except I need one a little bigger. This one is for a 3/4 pipe or conduit. 3/4 conduit. It's about 28 millimeters. I need a 30 millimeter punch. So I think I'm going to try to make one. It doesn't. I don't need it for. I'm not doing commercial use for it or anything like that. So it's not going to get overly abused. But I want it to last a little bit. So I need a. I have some W1. I think that will work just fine. I can heat it up and at least get it kind of hard, at least for the punch part. And I got a chunk of 8620 here. That's big enough to make this portion of it. So that just goes in there, right? Punches the metal. This is this slips on there, and then you thread it on in, sucks it up tight, and punches your metal, punches your sheet metal. This is a Greenlee punch here, and we'll make it fit the 3/4 drawbar. And let's go over to the lathe. I did make up a drawing, of course, of the punch right there, and I'll zoom it in a little bit. So it's not a simple drawing to make, I must say. I did it in Fusion 360, and all the angles and all that. It was a nice little challenging project to draw.
8,000 feet to 28% and 8,000 feet 27 to 37%.
There we go. That's the receiving half. Should work. Piece of W1. Now we're going to do this part of it, the punching part. We'll get all the diameters, the hole drilled and tapped, and then we'll do the milling for the two teeth. Okay, this is the punch side, all done. I threaded it. I threaded it on the lathe. I didn't have a tap, 3/4 16 tap, so I just did it on the lathe. So I didn't really film that. You can't really see much when you're working that close anyway. So that's all done. Counter board, and this is where we'll do the machining. And that's gonna go right in there. Oh yeah, fits good. It's a loose fit. It's a few thousandths. You know, like about 10, I think. So there's about 5 thousandths around there. That's gonna work nice. That threads right on. I think I blew it out with air, so now there's crap in the threads, but it goes right on. Anyway, oh yeah, here we go. So that goes through. Yeah, this goes on here. If you've never seen one of these, this goes on here. You put this through a 3/4 hole in your sheet metal, then your punch part threads on till it's up tight against your sheet metal, and you just keep going. This is a ball bearing. Boom, 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 and it punches it right out. These are great. These are knockout punches. These things are fantastic. That screws on down. You know, shouldn't all the way, but it's gonna work out good. We just got some milling to do. I'm going to attempt to show you the setup I have here to mill the punch side. So I have a punch in here. This is that 28 millimeter one. It's just a little smaller than this one. This is going to be 30. So here's our blank. And what I've done here is these are some compound angles we have here. So this angle here slopes away from that cutting edge. It has a gap. It's back from the cutting edge by 50 thousandths, and slopes down away, but it also slopes in this direction too. So what I did is I have my milling vise set up, of course. That's square. I have a sine vise, grinding vise here, set up at this angle, for this angle. And then I have a sine fixture plate set up for this angle, for in this direction. And what I did is I took my indicator and I indicated back and forth across here to get this angle set. And then I indicated from here to the other side, or from here to here, the same, to get this angle. And I set these up, and then I figured out basically the gauge block set, and I just used precision spacer blocks here screwed together to get the right heights to clamp them down nice and tight. And we're within a thousandth, so within a thousandth about of an inch. For an inch distance here, and about 3/8 or so of an inch here. That's plenty accurate, more than we need on this, but I did get them that close. Then what I have on here is I'm going to put some, these are just here for now, just to figure out how I'm going to do this. So what I'm going to be able to do is I'm going to come in and I'm going to mill this face here. This face is right on center line. And I'll mill that face and this side. Then I'll come over here, offset over 50 thousandths, and I'll do this side. So that will be done across that surface there, and that face will be done. This surface right here, you can see there's a break right here. This is at the same angle as this is this way, but it's flat or parallel with the base of the die in this direction. So it's just a single angle, not compound. We'll do those afterwards. So I'm going to do this one side, then I'm going to index this around, and then I'll do this angle on this side, and then I only need one vise set up to do this angle here. And then we'll get that set up. What I did is I made I'll show it to you when I disassemble all this. I made a threaded insert piece that's going to thread down in the side of this, then come up through the bottom, and I'm going to bolt that down like that. Now, I'm going to put a piece of paper in there for some friction. I'm going to mill it really gently, so hopefully I won't get any rotation, and we'll get it nice and tight. So we'll just see how it goes. You know, your approach angle and all that. And I just going to mention one little correction. Now these faces here are perpendicular to the base of the die, so I'm not going to be able to do that. I'm going to come off. I'll come up to the base where the base of this is, and leave the rest of that material, and I'll have to do that when I set it down flat, and I'll have to come in and clean those up so that they're square. Yeah, I'll just come into the base over here, and that way I'll leave a wedge here for me to clean up. So that was just one little correction, and then we just went across like that. Actually, that's within a half a thou, so that's pretty good. That's actually 0 now. How about that? So we're good. We like 0. So I loosened I have a 1024 screw, little bolt actually underneath there. And then I have this piece. I just screwed it in to here for now. I'll have to get that out. So I just had this. This fits actually the other one. This part here will not fit inside this one, this shoulder. So I just put it in backwards. So this is going to, you know, this is going to go inside here. So I screw this screw in through the center of it, and then I put a nut on it so it's tight so I can use it as an insertion tool. And I thread that down in there to seat. Then we'll take the screw out. And I thought about Loctiting that in. Since I've got my setup and my angles, I probably could do that. Alright, I Loctited it in. Now this bolt has a lock washer also on it. Alright, it's on there tight. I'm just gonna scribe a line across where center line is. A little update on fire situation. Well, bombers all day, helicopters all day, even the largest tanker, air tanker, they call them VLATs now, 747. Its very first drop, it flies international fighting fires. Very first drop in the United States was yesterday. I think it was yesterday, on the fire right here by our house, and it flew right over our house. I saw it go over. So very interesting. Fires, I think getting close to 3,000 or just over 3,000 acres. It's downwind of us. It's a ways away still, but it's probably the worst one of the season for us as far as threat goes, because it's downwind. The other ones weren't downwind of us, so I'm not real too concerned about it, but still we are concerned. It's not like we're not concerned, I should say. Okay, so and to lock those in, those will help position, giving us a corner for rotation, so I rotate on the same axis. Use a square here to line up my scribe mark, so that we're square with something, and it's going to be the edge of the we're going to be lining up with the squareness of the edge of the sign plate here. So I have my center line scribe mark there, that one, and that one. That's what I'm lined up with. And then what I did is I came in and I scribed over a little bit, 50, 60 thousandths, and then the other direction, 50, 60 thousandths. That's that little flat that I have to leave across the top of how the cutting edge here is kind of formed. They have a flat left across there. So that's the flat I want to leave. When we're done with this, these flats are also sloped back at the same angle as this angle was right here. These are sloped inward toward the center, just as this one is, and that's when we set it flat on here, and we'll be able to do both of those, then turn it and do both of those all the same. So, oops, there. We'll be able to set it flat and do this angle and this angle at the same time, and then rotate it and do the same thing. Alright, what I did is I ended up lining up just by eye the corner of my end mill tooth. This is a 4-flute carbide 3/8 back from the center line to form my 50 so thousandth, or just so. I just eyed it, and I'm going to just cut that all the way across. That will leave me a little wedge that I'll have to clean up. So we'll just do it that way. This is definitely into the realm of stunt machining, and we really don't know if this is going to work or not. I'm going to touch off on that back side. That's the high side, but I want to machine from the other direction. Still about 30 at a time here, probably. You want to do that way because it tends to pull it in the tightening direction, is why I want to do it this way. over on the grinder, and I have the punch set up in here. I ground half of one side already, and I turned it around, and I'm going to plunge down, grind the other side. I've narrowed my wheel down to 3/8 wide because that's how big a spot we want in there. So we're just going to plunge on in there and groove that. Then we're going to change our setup to one angle and do the outside parts on both sides. So far this is working, and we're gonna stick with it. Alright, what I did is I just dropped this down. I left all this in the same position. I just dropped this sine vise down, and now I'm ready for the next angle. Now I'm just touching up these so there's the same angle but inward. I already did this side. I just rotated around. Now we'll do this side. I just touch it off and then I'll move it this way until I make full contact. A little more. So it's taken, there was a little lip here and I'm just going down to take that off just like I did on the other one. To make them about the same surface area. Oh, that's pretty good. Let's take it out and clean her up. Well, the work holding and everything, that worked out pretty good. Happy with that. Grinding came out pretty good. We got some burrs and some cleanup here. I could have went a little farther over, it looks like right there, but that's minor. Other than that, it looks pretty good. I have my angles back because of the way we ground that, and I was thinking of squaring that up. I still could. It's a little difficult to do, but I still could do it. This one is squared up, vertical with the axis, or these slope back a little bit. But I'm going to leave them. I think I'm just going to leave them. I could do that though, but just leave it. I'll leave it on there. Rotate a little bit. Come in there. Rotate around. Do that again. I think it'll still work. I'm going to deburr it, clean it up. What it looks like, and get my plug out. I Loctited it in, so I'll have to warm it up and get that out. I'm going to heat these up, nice and hot. I'm going to use MAP gas for this one. I'm low on, I think I'm out of acetylene. So we're going to do that. We're going to do MAP gas on this, and this will be good enough for this punch. It might take a few minutes. Okay, I think I've been pretty hot. I wish it was probably a little hotter, but we're gonna go with this. General rule of thumb is critical temperature for an hour for every inch of thickness. If you could follow that, just if you're doing it by a torch. So this is not even this is almost a 1/4 inch thick wall thickness. So if I got it to critical temperature, 15 minutes really at critical temperature should be enough. Anyway, this is W1, so it's going in. Now we're going to do this one, and we'll do this one too. And then we'll temper them. Now I'm going to clean them up. Nice and black. We'll go clean them up though. So this is my set of hardness files. We're gonna test them real fast here. See how hard they are before we temper them. So this goes from 40 to 65. This one's I already went kind of through them, and 50 grabs, just barely grabs, and then 45 doesn't grab, or barely. If I push real hard, I can get it to barely scratch it. So it's right around 45. The other one though, I can't even scratch it with 65. It just skates across there. So this one's hard, real hard. I probably got this one a little hotter for longer too, just to make sure I got it through the full thickness here. So I got good hardening in this area. Not so much. It didn't have to be down here, but it's a small piece, mostly up in here. This one up in this area. It's not quite 60. No, 60's grabbing. Let's see, 55. 55 barely grabs. Yeah, it scratches a little tiny bit. Let's try 50. 50 really doesn't grab at all. So this top part is closer to 50. Yeah, barely can scratch it, which is just fine. Now we're gonna temper them a bit, so they're a little tougher and won't shatter on us. I got the outer part done. We just kind of watch it here and get it to warm up and get the straw color, and so it was going pretty fast. It was next to the other one, so it was kind of already warming up. There we go. Turn that thing. Just hold it there for a little bit. Now, some people ask, well, why water and why oil for quenching? Well, if you watched one of AVE's, Chris's last videos he talked about metallurgy and composition of steels. Well, compositions of steel, they've done a lot of testing and everything on it. So for composition and how to quench and what to quench them, and how much to heat them to, what their critical temperature is and such. Well, it's about cooling rate. How fast does the metal need to be cooled to lock in your grain structure for your hardness, your toughness and stuff? How fast does it need to be cooled? Well, like W1, they recommend so it's water. Water is the quenching medium. So that steel obviously needs to be cooled quickly. Oil cools much slower. Cools your piece, absorbs the heat much slower. So your O1s, your D2s, all that other stuff is oil quenching. So that material needs to be cooled slower, so it doesn't crack, so it locks in the grain structure for the steel. Now we'll test these for hardness, and we'll see what we got. See if they softened up a bit. Okay, let's just do this one. So we were about 50 with this one. Let's see now 50 actually bites in a little bit now, so it softened up a little bit. Let's try 45. 45, yep. Yeah, 40, yeah. Kind of hard to get 40. It's kind of hard to get 40 to bite. But it does, but a little bit. So it's pretty close to 40. So that'll be fine. So we got it to change a little bit, and so it should be a tougher material. Let's try this one. Now this one here was up there at 65. Oh, see, now that bites right in. I see I'm just trying to get it to bite. I'm hardly making a mark. You know, you don't have to sit here and file on it or anything like that. Yeah, 60 bites. You might be able to, can you see that scratch I made? Yeah. Anyway, so this is 55. 55, that's barely doing it. 50. 50's not. It's yeah, just barely. It takes the blue off, the bluing off, but it's really not biting in. So it's right there around 50. That's what I would say, right around 50. So there we go. There's our die punch. Now we need to go test it. And we'll measure that too. See how close it still is to. It's just a smidge over 30 millimeters, 30.1 or so, 30.2, somewhere around there. Just barely over 30 millimeters. And let's go see what it was, what it ended up being. I have a Greenlee Slugbuster knockout punch set, and it's all for, you know, ½ inch, 3/4, you know, 1 inch, 1 1/4, you know, up conduits, up to 2-inch conduit dies. So, you know, I modeled it after the little one, but you know, these ones are all really basically modeled the same way. They did them the same way. Anyway, so what you do is you first start off with your smallest one here, which is for a ½ inch conduit. So all you have to ever do is drill a 3/8 hole. So we'll punch that. We'll punch these. I'll do it a couple times, and nice ratchet. Makes a pretty nice hole. Okay, so this is some T6 aluminum, 6061 T6, and it's a 66,000 thick. So it comes out usually in 2 pieces like that. That's what the Slugbuster is, so it's not just a little disc. It makes it so the punch cleans out easier. There we go. Now here's the next size. This is 3/4 conduit, and then here's my new one for 30 millimeters. Then you go up to the 3/4 inch drawbar. This is the 30 mil, our new one. And that will fit right in there. Plenty of room to wiggle it around, get it centered up. See if that still screws on. Yeah. Oh, I was going to measure that. Let's use these. Change it to metric. We're right there at 30 point. It says 30 point. What? Can't get in the right place, I know. 30.15. So it's right there, basically the same size. Didn't really change any. Might have to put this in the vise. Another lovely fire start today. So we got 4 fires around us now. Really nice. I'm sure the smoke is going to be wonderful. But this new fire is only 9 miles away, and it's to the southwest of us. We're very concerned about this one. Well, Punched a hole. Might have to. I didn't clean those threads out really. It might be a little sticky here till we use it a couple times. I gotta hold the right part. Then we got two pieces, just as planned. I was a little off center, so it's a little thicker and thinner, but we'll do the next one hopefully a little better. We'll measure that hole. 30.01, right there, 30, 30.1, 30.05. So give me a perfect 30 millimeter hole. That's just, I mean, for this type of thing, that's perfect. A little bit bigger is always a little better. There we go. Second hole, 30.07, and then the other one was 30.05. Got the two pieces out. Very interesting build. Very satisfying that this worked out really nice. I made this for push buttons. That's why I did that. I didn't even look up what one cost. I know they make them specifically for all your push button controls and stuff. But I have the material and I have the tools to make it, and it's a good project. And now I'll probably go over here and engrave it with a diamond, what size it is. Thanks you guys. Thanks for watching. Please subscribe, buy a scribe, support the channel. Thank you.